Okay, so we're going to take a look at periodic functions, and we'll focus on y equals sine theta, and I think the next page, let's see if I can get to the next page here. There we go. We'll also do y equals cos theta, but we're going to do a bit of a comparison. You'll notice here and here that everything is in radians at the moment. So this idea, move it around a little, there you go, it's a little easier to see. This idea stems from what we did in a previous chapter where we're talking about like rotating around the Cartesian plane with the unit circle, and the unit circle to get all the way around. That's not the one I want. There we go. Well, to get all the way around the unit circle, you're going from 0 to 2 pi. Essentially, the idea is halfway is pi of a rotation, right? And we talked about how a radian is the distance of the radius measured along the arc. They call that the arc, same distance as a radian. What we'll do is we'll use our degrees as a reference, just so it makes sense, because I know it's something we're a little more used to working with. So instead of actually jumping right in and like punching this stuff into calculators and trying to get approximations of it, which is the same what we're going to do to here, we'll go take a look at the graph of the overview of a y equals sine theta, and then we'll try to deduce some of that information from there. So we're going to jump over here. Okay. Let's zoom out a bit so I can get to the home. Okay. Here's our home graph. I'm going to go in y is equal to sine x. Okay. And if we notice here, okay, and what's important here we're using Desmos graphing, you can go in the graph settings, and I'm already in radians. I can change it to degrees, but you'll notice we'll get a very different looking line. So what I'm going to do, instead of swapping between the two and having to zoom out and zoom in, is I'll just use another graph right beside it, and we'll just go back and forth between it. But in this one, I'll set this one equal to degrees, so we can get just a general idea. And the reason degrees is going to be so very different, you can see I can actually manipulate this. I'm going to change it to 720, and that could be 720. And the y-axis will go, I mean, that's a decent y-axis. Okay, so we'll talk about, these are 5 major points. This is the period of a sine graph. So we'll talk about some of the major ideas of a sine graph here. What you're going to notice, let's go to that. What you're going to notice with the sine graph is one of the major points is at 0, 0. Another one is at 90 and 1. Okay. Then we come back down here and we're actually at 180 and 0. Down here becomes 270 and 0. Oops, sorry, that's not 0. The y value is -1. And then finally at 360 and 0. Okay, so remember that this is the x value and this is the y value. It's the concept of going in a circle, but think about it being measured over time, right? If you were to travel on a Ferris wheel and a Ferris wheel was to go around, your height from the ground would actually travel like this. You'd go up to the top and then you come back down, and then you go up to the top and then you'd come back down. So it's showing this distance over time rather than the repetition of a circle, which we just worked with in the last one. These are the 5 major principal points, they'll call it, in degrees. And what we can do is we can jump over here and we can take a look at them also in radians here, okay? And a neat way to do this, what's neat about Desmos is I can actually change this into a table, okay? And it's going to give us some pretty good points. Not the exact one I wanted. Here, yeah, it didn't give us the exact one. I'm going to change this to, I should be able to make this at 0. Where are we? Oops. This will be 0. Great. This one's actually going to be, I would like to know where pi divided by 2 is. Okay. So I'm actually, our x value, I'm going to put them in those radian coordinates. Okay. This one's going to be 3 pi over 2. We're going to talk about it in a second. And then this one will be actually 2 pi. So though they're a bit odd, because these numbers themselves, if we write them in their actual form, they're not very nice numbers to look at. For instance, this number pi over 2, that's actually If we were to write out its long form, that's actually like 3.14, I think it's 1.5 divided by 2, which is going to be, 1 something, 1 something something something. So it's not a very nice number to look at. So that's why we keep it with the symbol of pi. It's just a lot simpler to work at. But this is the same concept as when we were jumping over here. You'll see that whether we measure in degrees or radians, the wave is periodic. It always repeats itself. So this x value is pi over 2 and 1. This one here is pi and 0. This one here is 3 pi over 2, which is just like 1.5. And negative 1. And then finally, this one here is 2 pi. So that's the full rotation and 0. And then actually this one is 0, 0. We should always keep that one in mind, okay? So we actually have them written over here. You can see what that little graph looks like. And I'll do the same thing with our degrees. Oops, let's erase the last two. Let's actually do this exact same thing. So this graphing program can come in very, very handy when you're actually trying to do 0, 90, 180, 270, and 360. So it's giving us some pretty distinct values here, okay? So this stuff's actually gonna be really important, remembering where these things fall, okay? So we'll use this as a reference as we jump back across what it is we're going to do. So let's jump back to our page, okay? And they've actually given us some values, okay? Luckily, we can use decimals to kind of solve this stuff. If you recall, put it back there. If you recall now, 0, its value is going to be 0. Whether you're exact or approximate, 0 is a very nice exact value. Pi over 6, though, pi over 6 is a bit different. So what we can do here is we can go into our radians, and I'm actually going to punch in pi over 6. So I'm going to go all the way down, and I'm going to say pi over 6, and this will give us our exact value, and it'll also give us some more information to work with. So pi over 6 ends up being about here, and it's not quite halfway between 0 and pi over 2, right? That would technically be pi over 4, but it does give us a y value of 0.5. So really what we want to do here is we want to go through this little page, and we're just kind of filling out some of the key information, okay? Approximate value. Well, our approximate value is about that. This is one that our approximate value is going to be a bit tricky because this is that halfway point between pi over 2, which is this one here. We know that value is 1, so we can say the approximation is 1. But this is where it gets a little tricky at pi over 4. So instead what I'm going to do is I'm going to jump to pi over 3. And remember that these actually also can be converted to degrees. This is the concept of like your 30 degrees, your 60 degrees, and your 45 degrees. Okay, remember that's how they convert in radians, because that's going to be really helpful as we go through this. So we have our pi over 6. I'm going to jump ahead to pi over 3, because it happens to be a little nicer to look at too. Pi divided by 3, okay? And it gives us, maybe 0.9 is the approximation, and the exact value is a little harder to get. It's 0.866. So let's actually write that in. And the reason I'm doing this all in the very first part is because I want to show you after 0.866. We'll say it's approximately 0.9. And then the halfway mark, we'll also do that. Pi over 4. Okay, pi over 4 looks like it's about 0.75 or 0.7. 0.77 is the exact value. So we'll put that in. But this next part is going to be where it's going to be coming point 0.707. We say it's about 0.7. What's important next is because this is periodic, what that means is periodic is the concept of repetition. So at this point in our graph, in our sine graph, we've actually gone from 0 and we've gone up to 1, okay? By the time we get to pi, we're going to be back at 0 again, okay? We're going to be back at 0. So in other words, we're actually going to revisit each of these positions on the way down, assuming that the distance between these is all the exact same. And at a quick glance, yeah, that looks like exactly what it is. So instead of actually going to a calculator or anything, we can just repeat these. We've gone from our axis of symmetry, which is usually called the middle of it. And we've reached our peak, which is the top. That's the value of 1. And now we're going to come back down. So I can just repeat these values in reverse order. I'm going to say this one is a 0.866, which is approximately 9. This is 0.707, which is approximately 0.7. This happens to be 0.5, 0.5. And then when we get to pi, we're actually at 0 again, okay? And then what happens, and we're going to go take a look at the sine wave again, is if you notice, at this point, it starts to actually become negative. So we've got the pi here, and all of these values are going to repeat just on the negative side of 0, right? Because we're actually traveling down to -1. So I'm going to jump back. When we get to 3 pi over 2, that value is -1 and that value is -1. So we can actually use a lot of this information, but just in its negative form. So as we start to go down, this is going to be -0.5, -0.707, -0.866, and so on. We can fill out the graph the exact same way, and then we can have our approximations, 0.7 and 0.9, and then so on. Okay, and that's the idea of this being periodic. It's both symmetrical on the x-axis and it's symmetrical on its peaks and troughs. It does the exact same values when it's coming up and going back down. So this is important. The numbers seem very arbitrary, but they actually become very, very important as we go to fill out this type of information.